eyes, please. What's up?
Is it on the input over there?
Yeah, we're on the right one, but so
Hmm?
Appreciate your patience. Just one
No
second.
problem. Yeah.
That's about it.
I'm just trying to get the color, the cable right in.
Yeah, they're just fixing it. It was a splitter issue, and they should just about have that now. And they did 1 second ago.
Yeah, but it keeps coming on and going off. So
We'll have it one more moment.
yeah,
Just one
yeah,
more
no
patience.
problem.
May I just shout at them and tell them?
Um, hello, hello. Sorry. Just to keep you informed, we're having a little issue with the beamer, and as soon as this is sorted, we'll move on. Okay, seems to be.
Almost there. 1 second.
Sorry?
Is it supposed to be gray or is it supposed to be in color?
Gray, gray.
It's supposed to be gray. It's supposed to be gray.
Yeah.
So if it comes out tweaked, we might just have strange display color. Is that okay? That'll be fine. If it's a little off color, let's keep it in mind.
Yeah. That'll that ought to fix it.
Okay, good.
Yeah, I'm supposed to be beaming now.
With that, I don't know why the colors are off, but we're going to have to keep that. I hope that's okay.
That's okay with me.
That's it. We're going to keep that.
Check, check, check. Check, check, check. Okay. Sorry for the. Sorry. So sorry for the delay. 10 minutes of my time, but I'll just speed up in the flow of things. So this is Invoke Empire Dog merging Bloodhound and Empire. Merging Bloodhound and Empire for enhanced red team workflow. Hello, hello. My name is Sad Processor, born in France, living in Holland, working in Germany. I'm a security consultant for ERNW, a small family-sized company that does very big stuff. Okay. My part in this, I do mostly PowerShell automation, and I try to build tools or a little tooling to assist customers. And other stuff I like, so electronic music, Photoshop, and there's a few in my deck. Lego Tetris, that's for the kid in me, the geek. World Food, first time DerbyCon speaker, so I'm very much stressed to be standing here right now. And okay, I'll lean in. And yeah, Forever Noob also with the microphone, with everything. Like I said, I'm French. You will see that not every French person presents in an underwear. That one is just for you. I didn't have any Kiwi ones. Just a quick word. I know this is DerbyCon, but we're all into security, one big family. So I'm just quickly reminding that Troopers is the CFP, CFT is open, and we're this year having a double Active Directory track. So if you have anything to submit, send it in. Come to Germany, and yeah, better like this. Okay. So last year was a fantastic keynote by Matt Graeber, where he told us to follow our shiny objects. So this year I decided to come and show you mine. And, so these are my tools, and I'll be presenting them today. So on the agenda, so tools and demo. It's going to be only tools and demo. First tool I'll be presenting is Empire Strike, which is a set of commandlets to work with Empire. Then I'll be presenting CypherDog, a set of PowerShell commandlets to be working with Bloodhound, and finally Empire Dog, which kind of automates on top of both of these modules. Why do I choose PowerShell? Simply because it's cross-platform, work with objects. You can use the pipeline. I just love it. So there's going to be a lot of PowerShell in here. My hope is, like, I know people are moving away from the PowerShell tradecraft on the system that is being attacked. I still believe PowerShell to build your own toolings on the side of the attacker is a fantastic framework. So this is my my language of choice when I build tools. So let's get started. Empire and Empire Strike. So what is Empire? Empire is a PowerShell and Python post-exploitation framework. And just to put it in a context, I guess you guys are all red teamers or security people, but just what is post-exploitation? Basically anything that happens after the exploit. And here you will see situational awareness, lateral movement, privilege escalation, persistence, data collection, and exfiltration. So I mention these because all the modules that you will find in Empire are also sorted by these categories. So this is a handy way to find your modules. Features from Empire, so PowerShell without PowerShell, in-memory execution, multiple communication profiles, secure communication, cryptography and everything. More than 280 modules, mostly built by the community. And I'll just mention one that has been fully incorporated inside is the obfuscation by Daniel Bohannon. And one that I would like actually is to map all the modules to the ATT and CK framework so that you could like work with all this at the same time. Credits, so always give credits to the real creators. I just build my tool on top, but yeah, Harmjoy has been a big inspiration for me. And behind here, the Shellfather, or Jeffrey Snover, is also yeah, the guy who laid the foundation for PowerShell. That's what it looks like, and I'm not going to go too much into Empire itself. And I'll present now Empire Strike. So Empire Strike is a set of commandlets to interact with one or more Empire server via REST API. So one or more makes it actually quite flexible, and also you could be more users working on the same server at the same time. So it becomes a team server, basically. These are the commandlets you will find in this module. So all of them start with invoke Empire as a lazy way to use the verb in PowerShell. But you can remove all this and just use these commands as alias. So it's very quick at the command line. Features, so we'll have full control via REST API, multiple session, easy syntax and aliases, tab completion, IntelliSense, and of course pipeline input, object output, and extensive help pages once I get to fully write them, basically. They're not fully there yet. Yeah, this is something also I submitted this talk and I thought I would have more time to develop everything. I've had a busy summer, so I'm still struggling to follow Captain Jesus and Harmjoy's development, but I'm catching up. So let's start with sorry, with the demo. I'll show you some code first so you know what's happening. So here, can you all read the code? Yeah. I'm just defining some variables, and then we're gonna start the action. So I make in the demo, the computer will talk just to make it a bit more interactive. And here you start to see the Empire Strike commands in there, just to show how easy it would be for you to write your own automations with all this. So what we're going to do basically is connect to the server, create the listener, copy a stager to the clipboard, then I'm going to infect the target machine with this listener as a way to simulate phishing or any other type of foothold. Once this is done, we're going to wait for the agent. When an agent come in, we're going to start a loop where the automation will check if this agent is elevated, and if not, we'll auto-elevate the agent and install persistence and ransomware on the target machine. So the code is not that complex. If you were to read it, you see. So we say something. We use a module here. We set an option for the listener. We set the option here. We launch the strike, and we wait for the action. So basically, these little 5 lines of code are all you need to automate it. And if you have, like, once you saw the demo, maybe you can go back to the code and you will understand a bit more what it does. So I'm going to comment. So this is my target machine. This is my Empire server. And you see for now, no agent, no listener. I'm just loading the module. And then I'm going to run it as a script. Of course, if you were at the command line, you could do it. So I'm logging in the server. And you see on both screens. So we're waiting for the initial agent. I'm going to simulate this on the target machine by simply pasting my stager. And you're going to see immediately on the server on the side that the first agent comes in. This was a little warning. Attempting to elevate the agent. You see another agent calling in on the server. And you saw the screen flickering on the target. I don't dare to touch anything because... So the persistence has been set up. Now we're setting up ransomware, which is just a wallpaper to simulate the effect, but could be any other type. And they are quite handsome, eh? So now I'm simulating a reboot just to show that persistence was installed on the target system. And you should see a new agent coming in on there. So here from a server that had nothing, that no listener, no agent, we've in one hit of F5, we've set up the listener, get a stager, infect the target, elevate the initial agent, install persistence, and ransomware without the hands. So it's all automatable, and this is again just an example of what you can do with it, but all the modules are accessible, all the options are settable, so it's a nice way I think, to control the Empire server from outside. Next step for me on this is to upgrade it to Empire 3.0, which is already in planning, I believe, from Zoyor and all these guys. Make it PS Core compatible so that you can also use it on your Linux or any box you're working on, basically. Write more commandlet and eventually at some point write an automation playbook so you will already have recipes for basic repetitive action you do on the server. Do we have any questions so far on the Empire Strike side? So the code will be up during the weekend. I'm still updating a few stuff last minute. I think like we all do when we come to conference, we like to add features and break everything, but the code is on the way. Now, Bloodhound and CypherDog. So Empire is a real offensive framework for offensive operation. Bloodhound is just here for situational awareness. So once you have your foothold, you can run the ingester, collect all the data from your Active Directory, bring it back into the server, and use this as a base for your operations, basically. The background for Bloodhound, so it's thinking list, attacker thinking graph, and as long as this is true, attackers win, something like this. I think this was a foundational blog post that kind of attackers think in autographs. It's a REST API, so Cypher being the Neo4j language that we use under the PowerShell commandlets. These are the commandlets you have available in this module. So I this time used real verbs because I got a remark from Jeffrey Snover that I wasn't following the best practices, so they're all changed, and it does make more sense. You know what you get, you know what you set, so it's a bit more, it says a bit more than just invoke, basically. Features for this tool, so full control via REST API, database manipulation commandlets, and this is something that Waldo touched a bit upon, but making hypothesis on your graph, changing a bit the relationship, seeing if you get less. So this is possible with these commandlets. And again, easy syntax, oops. I have here my Bloodhound, so I have a sample database inside that is completely corrupted, so it looks very strange, but it was for me to be able to work on this, so I hope this will work for you guys. So if you simply say Bloodhound, you will have all your commands and a little bit of explanation. Then you can start looking at users, for example, and he will spit out all the users. If you like it more in a table format, PowerShell lets you do this. And we're here dealing with objects, of course, so you could start manipulating this object, dot referencing the properties and everything. So that's your list of users. You can, of course, get a single user if you like. And all the other types of node in the exact same way. So all your computers, your groups, your GPOs, your OUs, they're all here with their attributes, basically. Now, if you were to search for a node, you can you always have to specify what type you're searching for. So node search and then user computer group. I took out all the ticks, so you can just simply write it like plain English almost. And here, oops. So I'm returning a user that has server in the name. I can return a computer that has server in the name. More interestingly, you can get all the users and return, for example, has SPN equals true. So spin users. On the side of computers, you can filter by property also, so of what you're looking at. So here, of course, I'm asking for users, so there's no relationship, but you can use this dash cipher switch on all your commands, and I'll show a bit more later. Here I was asking for all the users member of the group, and I specify the group. You can, of course, do the opposite, and you're asking actually a different question to the database. So here I'm asking for all the groups where this specific user, HW at domain local, is a member of. So the syntax is user HW member of group, and you get the groups he's member of. this is awesome. This has been added by Captain Jesus in the latest release of Bloodhound. So all the edges, if you, I'll show you here. Let me get a path. Shortest path to here. So any edge, if you right click on it, has a help. Well, any, not the one I chose here. There's one missing. Did you see that? One doesn't open up. Okay. And here you start to get a bit of info on how you would start to attack this edge, or how you would start to move along this edge with the abuse info, the OPSEC consideration, and the reference. Everything, all of this, I have added also to the command line, so an operator could at the command line say, okay, I have here member of, how can I attack this? And you get the exact same info that you would get on the in the UI. Of course, you can query path, and here it's a very short path, but from this user to this group, I can query the same path and specify I don't want no ACL. And here you see that this is actually giving me a longer path. Very often the ACL paths shorten the attack path. So here by asking without ACL, I get them, oops. Let me format this as a table so you see it better. So this is what a path would look like at the command line. And the idea would be in a third module, in the Empire Dog module, to have a semi-automated way of following this attack path, by asking you which module you would want to run for each edge, basically. That's not developed yet. I can ask for a path. I can show you this one actually in the UI if you want. Oops. So it's a bit of like moving back and forth, but as soon as you say cipher, you can go back in the tab, paste it in, and you get the equivalent of what we saw in the command line. We have the equivalent here. Can I do this? Yes. So you see my path here. You can, of course, ask a path to here from this user to any group. Of course, he returns more path. The Bloodhound graph can sometimes become a bit overwhelming of asking this query here. Sorry, oops. Which is actually just a path from the user to a group from HW domain to any without ACL. Yep. And I can do the opposite, and you're going to see that it looks like the opposite in the graph. So this time all the paths that add up to that finish on the group that I was targeting. So from any to that group, or from that group to any, queries have a, or path have a direction, so you need to respect that. Oops. Following the idea of, or the supposition that a member of has no cost when you're attacking a path. So I kind of wanted to calculate the cost of an attack path, not only by counting the amount of hops you would have to make to get there, because for me a hop of member of has a cost of 0. So this commandlet here, path cheap, is a shortcut to not counting member of as 1 in the cost, and then he takes the cheapest. And what I do to get this is actually I ask for the cheapest path, and then I expand the maximum distance, and I ask him for the cheapest even in a longer one, so as to be sure that you do get the cheapest path of all the possibilities. Sometimes a longer path could actually be cheaper because it has more member of in it. So you can, in this way, you can quickly see which one would be the easiest to follow. Another cool feature, cross-domain member, will give you all the members that are member of a group on one side and have access on the other side. So here I have two domains, and you see that domain from domain local to BSC local, account op domain has a member of account operators. You can also extract metrics from the database. So here I'm asking for the top 5 admins in this network, and you see that my top admin is FK at domain, and I could also ask for the opposite, so see all the computers that are administered by this user. So it's a very quick way to navigate. Members of a group, I can ask them like this, not very interesting. This here, Waldo.io, is the Waldo index. Oops, let me do this. And what it does actually, for a given group, it will calculate the amount of inbound users, so how many users have a path to that group, and what percentage is this of the total amount of user of your Active Directory, and then outbound computers. So all these users can access that group, and from that group I can access all these computers. And you see here that actually 65% of my users can access 100% of the computers. I added here the amount of hop, the amount of computers touched on the way, and the cost of those paths. So this is a quick way. You can like pass it all your groups and pipe it to Waldo.io, so you would have a report of all the groups and their input-output in your whole Active Directory. Okay. Database manipulation, so I'm going to go very quickly over this, but here I can create a user and properties in one go. I'll create Bob and Alice. Then we can have a look at Bob and Alice, and they've just been created. We can search who has a property of color blue, for example. Did that work? Nobody. Red. Alice, yeah. Now I can update just the property and see that now Alice is in blue. Here, so another nice feature added in the framework is that if you take a user, for example, you can add notes to this user directly in the UI. Not if you're on a dark theme, you won't see it, but it still is here. But the dark theme doesn't has white letters in it. So what you can do in that case is simply, for example, here, add a note to the user Alice, and simply by adding the node switch on your node user Alice query, you will get the notes back out of this user. The idea here is that you could eventually execute commands and pipe the output directly to the node nodes if you wanted to, for example, to keep track of your activity. So I created those two nodes. I'm going to create an edge between them. I'm going to use the owned edge. This is just to show you the cipher that is behind it. And now if we check which user owns user Bob, you will see that Alice comes out, basically. And you could also request, of course, a pass from Alice to Bob. Alice owns Bob. So there's only one edge here. Another interesting one, so when you have a user or a group, you can, with a right click on it, you can mark as high value, and you see the little diamond icon appears on this user. You can do the same thing from the command line, and you could here do it at scale by passing it a full list of user, for example. But I'm just going to mark Alice as a high value. And if I go back in my UI and I ask for Alice, you see that, oops. Not sure why I'm not getting the icon, but I'm getting the little diamond. I'm just not getting the user icon anymore. And then, of course, I'm going to delete those users. I don't want to pollute my database. And they're gone, so it tells me the Alice and Bob are not in the valid list of users. So that's the idea behind CipherDog. I think Bloodhound is a fantastic platform for like gathering all your information during the engagement. And for me, having a command line tool to do this at scale allows for very quick, like if you have to mark 10 users as high value in the UI, there's an amount of clicks that can be skipped. So that's the idea behind all these commands. I'm really late, so I'm gonna speed up. Sorry. CypherDog. So what's next? Keep up with Captain Jesus. The guy is a real coding machine. So yeah, I spend my weekends trying to understand what he do and adapt. Also make it PSCar compatible. I would like to make it multi-server so that you could have database in different places and query them from your command line without having to switch the database in the Bloodhound UI. Where are we? Now, last bit. So Empire Dog, which is simply like mixing Empire Strike and CypherDog together. Set of PowerShell commandlets for Empire Strike and CypherDog automation. For now, I have only these, but I'm writing more at the moment. DogMap is a automated way to map your Empire infrastructure in Bloodhound. DogBark is a way to return nodes. And DogBite is a way to set the target by specifying the Bloodhound node. You set the target in Empire, basically. Featured, yeah, that's what I just said. So automap Empire assets, auto-select agent via node name, pipe agent output to Bloodhound node, automate owned or high value at scale, and then later write more offensive recipes. Quick demo to finish. I'm not going to show you the source code because I don't have time, so I'm just going to do it like this. And this is where I'm going to map and manipulate the Empire. So here I have only one target in Bloodhound, and I ask for Empire map showing me all my Empire. I have nothing. Here I have one server, no agent, no listener. I'm going to create all this like last time. So simply log into it. Yeah. Show that there's no listener for now, no agent for now. Then I'm going to create a listener. I'm going to use HTTP, create with the default name HTTP, and you see my listener is started on the server. You can also see the little bits of code coming in on the server side. I'm creating an HTTP com just to have two listeners, and now if I list, you see all my listeners and their names. So again, it's just object. You could tap into any property. And I'm gonna now DogMap. So DogMap will take all this data from my Empire server and come and import it into Bloodhound. So now if I ask again for Empire Strike, you see my infrastructure is starting to be laid out on the graph here. I can DogBark session, and it gives you the session you have in your Bloodhound map. It gives you the listeners you have. I still have no agents, so I'm gonna use a multi-launcher for the listener HTTP. I'm gonna generate a stager to my clipboard. I'm gonna go infect the target, I suppose. Yep. So this is the same setup than last time. Now you see the agent checked in. So if I do agent list, I have my agent available with all the properties. I can execute a command against this agent, and this is just to show that we return full objects. Even though Empire would return strings, you can trick it to return a JSON string and open it on the server side or on your side. Now I'm mapping it, and you should see my agent being added to the map and the target he's running on. That's my agent. Now I'm gonna connect to a second server, and that's this one here. We're already a listener and an agent to gain some time. Once this is logged in, I'm gonna map it into Bloodhound again. So it's basically querying Empire, getting all the objects and pushing them into Bloodhound. If I map again, you see that I now have my second server or session with another listener here. Now we're going back to session 1. I generate a stager for that listener I just created. I have it in my clipboard. I go back to session 0, which is the one you had an agent running on top, and I execute my stager against the agent that I have running on the target. Now, you see here on the server, he receives my command, and on the other side, you will see a listener or an agent checking in. So I basically passed my listener from one agent to another via myself. And if I map this again, you will see now that there's a new agent that's been created on the HTTP1 session this time. So that's a simple demo of what you can do with it, but the idea would be that you can fully integrate them to one another, basically. What next? So more commandlets, automation playbook, and documentation if I get time. Where to get more info? So on the Bloodhound Slack, Jesus answers quicker than Google, so just do it. The invite is on the bottom if you're not there yet. It's really a cool place with more than 2,000 people chatting about red team stuff, so it's a cool place. This is where you will find the code. Again, probably by the end of the weekend it will be uploaded or on there, so the 3 modules. And that was about it for today. And just, yeah. Poor. Huh? Good. Yeah, it was a bit of a mess, but
Looks good.
Mic check 1 2, check 1 2. Check 1 2, mic check 1 2.
We'll give it about another minute. I guess that minute is now. I'll get started. I want to say thanks for everyone to coming out to my talk, When Macs Come Under Attack. It's a pleasure to be here at DerbyCon. This is my first DerbyCon. It's been an awesome con so far. The community is amazing. I'm glad I'm able to talk about something that I enjoy, which is macOS detection and response. So let's jump right into it. My name is Richie Cyrus. I'm currently adversary detection analyst at Spectre Ops. I'm an Apple fanboy, and sadly, I'm a New York Knicks fan. We've been horrible for quite some time, so. Prior to Spectre Ops, I cut a lot of my teeth in the private and public sector, most recently at Apple. I was on the incident response and monitoring team. So a lot of what this talk consists of came from my time at Apple and what I wasn't able to share. But now that I've left Apple, I'm able to share some of this information that might help you in your enterprise when you go about hunting for macOS malicious activity. And so a little bit about the outline of this talk. So I'll go into like the need for macOS threat hunting and then what the macOS attack landscape looks like today. Also the hunt methodology. So a lot of people bring up threat hunting, but they don't know what it is, or they might have some skewed view of how to go about doing it. So I'll introduce the hunt methodology that we subscribe to at Spectre Ops. and then some of the tools and data that you'll need to hunt. And then we'll go into adversary techniques and detections of these techniques that I'll introduce. And then a cool little demo where I'll introduce like what an attack looks like on the offensive side, and then switching over to the defensive side and looking at that activity and picking one technique and hunting for that activity. So there was a series of commercials back in 2007 in which you have the Mac versus the PC. The guy in the suit is the PC user, and the guy with the cool hoodie is the Mac user. And right now in this commercial, he's taking care of the sick guy because he's come down with a virus. And the PC guy's like, yeah, there's a bunch of these viruses going around. There's over 100,000 of these viruses. And the Mac guy was like, oh, poor thing. Sorry for you. Macs don't get those. Well, that is false. Even back in 2000, even back as far as 2006, you had the leap worm, which was pretty significant on Mac OS systems. And so even back then, it wasn't maybe as prevalent as Windows viruses and malware that was going around, but Macs did, in fact, have viruses. And so a lot of the marketing that Apple had back then and even today is like, okay, the nomenclature that Macs don't get viruses. Well, that's simply untrue. And so in order for us to hunt for malicious activity, you have to come to terms that, hey, there are malicious activity going on Macs. Like Macs are getting hit with malware, right? And so that takes us to today. Well, what I mentioned, Macs are getting attacked, and so a lot of what kind of, pushed this upward thread was that as you get more Macs in the homes of users, as you get more Macs in the enterprise environment, you think of your enterprise environment, your security team wants a Mac, your developers want a Mac to do their work, your higher-ups want a Mac because they think they're cool and they want the Mac, right? And so these are the folks with the most to lose. And so attackers know this, and as that market share goes up, they're going to become more interested in writing malware for Mac OS. And so to piggyback on that, there are also APT groups that are now interested in Mac OS. You have X-Agent that was used by APT28, also known as the Fancy Bear folks. And then you have Ocean Lotus, which was tied to APT32. And so it's no longer that game where there's Mac malware being written out there to just do stuff like adware or to get some monetary gain. There are actual nation states interested in Mac OS systems and doing them harm. So you also have vulnerabilities that occur on Mac OS systems that leave them susceptible to major attack. I don't know if many people are familiar with the IAM-root vulnerability, where you put in root as the username and you hit password a few times. This was back in last year, 2017. And if you press that enough times, you would get root on the system, right? And you have elevated privileges to do some nasty things. So kudos to Apple for cleaning it up pretty quickly, but in that window of time, the landscape was wide open for attack. And so I'll talk about what the Mac attack landscape looks like today. So a lot of the Mac attacks that you see, well, one, you see macros there, right? Because if there's macros that are there to exist, they will be weaponized to distribute malicious activity. Also PDF documents, right? So that's one way, getting that in email. But then a more interesting way that you don't see too much on the Windows side, but you're starting to see it on the Mac side, is like supply chain compromises. So the tool Handbrake that's used for video encoding, the mirror to download that tool was compromised. And so what the attackers did was they embedded some malicious code into Handbrake, and then they added that to the download mirror. And so when you go to download Handbrake, you think you're getting a true copy, but it's backdoored with some additional malicious code that will persist on your system. The same thing happened with Transmission that actually distributed Mac OS ransomware. So that was the first time we saw Mac OS ransomware in the wild, is that supply chain compromise. And then, I mean, if any of you had a Mac or you have families that have a Mac, you've come across an ad where it says download Adobe Flash. That's almost never Adobe Flash. And so that's how users get compromised as well. And so threat hunting, right? What is threat hunting? How do we do it? Well, at Spectre Ops, we like to subscribe to the methodology that threat hunting is actively searching for malicious activity that has evaded the defenses that you have in place, right? So your EDR tools, things that you have monitoring your network, your firewall, whatever you have in place defensively, you're assuming that the attacker has knowledge of it or has been able to bypass that. And so you're looking for malicious activity in spite of those defenses being in place, right? And so why we hunt is here. So Michael Hayden, which was the former director of NSA and CIA, he says, fundamentally, if someone wants to get in, they're going to get in. You're in the fight, acknowledge that, own up to it, and you're most certainly penetrated, right? And so that's a lot of the assumed breach mentality. And so if you take the assumed breach mentality, as Matt Graber eloquently stated here, then you kind of introduce the attacker's dilemma into the equation, right? So the attacker dilemma, for so long, me as a blue teamer, I've hated this for so long, where an attacker will say, oh, you know, the defense has to get it right so many times. There's so many holes that they have to fill. If I get into this, you know, one system, then it's game over, right? Well, if you assume that you're breached, then you start to flip that on their head, right? The attacker has to do so many things right not to get caught once, because once they get caught once, it kicks off the IR process, and you have evidence of someone being in their environment, so your security awareness is heightened, right? And so we go into now, how can we detect attackers' behaviors and activity post-compromise, right? That's the big piece that if you could do this well, it'll take care of a lot of the things in your environment as far as post-compromise. And so it'll be nice if we had a framework that can display to us all the behaviors and activities that attackers could do post-compromise. Well, that's where MITRE ATT&CK comes in, right? And so MITRE ATT&CK is a framework for describing the behaviors of cyber adversaries across the intrusion lifecycle, but the majority of the framework is focused on post-compromise activity, which is ripe for threat hunting, right? And so it's pretty convenient to answer our question, and documented in the frameworks are the tactics that are being used by the attackers, so that's like high level, and then the techniques that are being used, so the specific thing that they use to accomplish the tactic, and then the procedures goes into, well, you know, the specific actions that they took to carry out their technique. And so MITRE ATT&CK includes Mac, Windows, and Linux, but we'll be primarily talking about Mac. And so we can use this framework for hunting. It's ideal. What we'll do is, in the hunt methodology, we'll identify the tactic and the technique that we want to hunt for, and that's, you know, guided by your upper management, that's guided by your threat intel team, saying, okay, well, maybe you're in the financial sector. These are the types of attacks that you might come across. And so with that, you say, okay, well, what are the techniques that we might come across, and let's hunt for those techniques so that we're ahead of the curve, right? And so once you identify the tactic and the technique, then you go about identifying the procedure, right? How specifically are they carrying out that technique, right? There's multiple ways to like add a user to the system using like net, right? And so after that, you want to identify the collection requirements, which I'll get into, which evolves around like data and collection of data. And then you want to identify the scope, right? So do you want to focus on just like the enterprise systems in totality, or do you want to focus on maybe the systems that the executive staffs have, maybe the security team's systems, or maybe the developer systems, right, in the case of Mac? And how long do you want that scope to run for? Do you want to hunt for a week? Do you want to hunt for a couple months? What does that look like, right? And so what we subscribe to is that folks should hunt for a specific technique and tactic for about a week's time, right? And then from that, document what you have so far and let the results from that documentation lead into the next hunt and keep moving along. You don't want you know, to be stuck in like a paralysis cycle where you're worried about finishing a specific hunt to the point where it never gets completed, and that's all you worry about. And so if you adapt this hunt methodology, you start to create a minefield, right? And so this is what I talked about before, where you kind of guide the attacker to where they need to be, right, on your system to do a compromise. And so if, let's say you knock out everything in execution, right, these detections or analytics, it kicks off the IR process, and you're able to respond to it a little bit faster. And so when you're hunting, and the more times you go through this iterative process, then you're able to take a technique, take a tactic, and dive into the details, and then the next time that an attacker or your red team comes across that, you'll be better equipped, right? And so in order to create this minefield, you need to have the data to represent that, right? And so the cool thing about MITRE ATT&CK, it has the data sources section in which it tells you what data source you need to actually make the detection come to life, right? And so I use the API that MITRE has to extract these details from the data sources, specifically for macOS. And so for process monitoring, file monitoring, process command line, and process use of network, those were the highest, right? So from those 4 items, if I were to build detections off of those, if I collected that type of data, it'll give me the best chance to start to create that minefield and knock out as many techniques as possible. And so I'll go into some of the tools that you can use to do this, and all of these tools are open source. And so you could go home today, try this in your lab environment, deploy this in your network, and get some use out of it. It's free to use it. The first tool I introduced is Google Santa. So this was a tool that was developed by Google's Macintosh operations team for the purpose of binary whitelisting or blacklisting. But the thing that's cool about this is it also gives you process monitoring, right? So that gives us one of the data sources that I described just now. A lesser known tool is XNewMon. It was written by Daniel Roethlisberger. And so it's designed to mimic Sysmon. Who's familiar with Sysmon for Windows? And so the idea behind this is that it's going to be Sysmon for Mac, right? So it has various event IDs. One event ID is basically monitoring for the agent. This XNewMon is persisting via a launch agent. So it's monitoring for the agent. If anything happens to the agent, it'll log. It'll give you that event ID. Also, if there's anything going on as far as like process command, like process injection, you typically have to call task for PID, right? And so that's like another event type that's there. It also does process monitoring, which is another event type. And it logs persistent items, which like launchd, launch agents, launch daemons, which I'll get into, and that's a separate event type. So anytime that you have a process execute on a Mac, the cool thing about XNewMon that separates it from the rest of the group that does process monitoring is that it'll show you the process, it'll show you the hash of that process, but it has a cool feature called ancestors, which will show you not only the parent process for that process that just executed, but all the way down through the tree to the process that kicked that whole thing off. So for Macs, that process is launchd. That's similar to like init for Linux. And so it'll show you that ancestry from the process that just executed all the way down to launchd, which is pretty cool. And last but not least, OS Query. So if you do Mac Defense, a lot of people are familiar with OS Query. And so what OS Query is best at doing is tracking persistent items, right? Because one, OS Query has some scheduled queries that you run across your enterprise in an SQL format, right? So all of the data that OS Query collects is sort of thrown into a database, and then you can interact with that database with various tables that you have access to. And so the cool thing about OS Query, it does file integrity monitoring pretty well as far as Yara scanning and process monitoring. The process monitoring for OS Query piggybacks off of auditd, which is a little bit kludgy if you ever work with that in an enterprise environment. But for the process monitoring piece, you would probably want to go with Santa or XNewMon. So I'll get into techniques that are used by attackers now. Well, the 3 most popular tactics that are used by attackers. So the first is persistence, right? And so the idea behind persistence is like the attacker has compromised the system, right? They've either fished their way in or found some other mechanism, but they don't want to lose that access to their system, right? It's a pain. Speaking to the red teamers on my team and red teamers throughout the community, red teamers hate phishing. It is a chore. So they want to make sure that they maintain persistence just so they don't have to phish anybody else again, right? And so the most common way to do that on a Mac OS system is through launch agents and launch daemons. So the idea behind launch agents and launch daemons is launchd kicks off the process. So that's the first process after the bootloader kicks off, and it's the first user land process that exists, right? And the existence of launchd is to kick off and load everything that's in the system library launch daemons folder, and then everything in the library launch daemons folder. And what that is, those are like system level functions that will happen. They're like more like services. And so when a user logs into the system, then the specific launch agents and system library and the user's individual library folder will execute, right? Or be kicked off or load into the system. And so if you've never seen a launch agent or a launch daemon before, here it is right here. And the key behind it, the major key behind the launch agent or the launch daemon is the run at load, right? So if run at load is set to 0, then it'll be on the box, but when it's loaded by the system, it just won't execute the command that's in the program arguments, right? So with every launch agent and every launch daemon, there is a associated binary with that launch agent or launch daemon, and that's what actually executes at load, right? And so attackers have been making use of this for quite some time. The first image at top is from the cold root rat that exists out there. And so with the cold root rat, they use the launch agent of com.apple audio driver, right? And so the intent behind that was to actually blend in with a lot of the launch agents and launch daemons that exist on the macOS system. A lot of them start with com.apple if they are created by Apple. So if you're an attacker, you want to kind of hide in plain sight. So there's nothing preventing an attacker from creating a launch daemon that starts with com.apple. The second iteration here is from some malware that was distributed through a site called Mac Update. And so the Mac Update site is by itself pretty sketchy, but there's some legitimate stuff there. And so what they did was it was a supply chain compromise, again, in which they were able to embed some malicious code into some of the applications hosted there. And with that, you see that launch control was used to load the macOS update.plist. And so that plist looks similar to what's here, but this is the plist for Little Snitch, which is a tool used for Mac for monitoring connections in and out. And so with that, once launch control is called and it's loaded into there, then from now on, when the system starts up, then it will call that executable, and that executable will run. And so when we start to look at launch agents and launch daemons in an environment, there's a few things that stick out that you could automatically count as malicious, right? And so this is a great example here from the co-root rat. And so you see the use of the com.apple, prefix, right? But you also see that the binary associated with it is unsigned, right? So that's a red flag, right? This code wasn't signed by any official entity. And so you can see the startup binary there, but if you take a deep look at the startup binary's location, you see that it's in temp, which is suspicious, right? Most of the time when an attacker gets onto the box, they might be restricted to where they could put specific files and binaries. Most of the time, you'll find these binaries ending up in temp. And so from this now, knowing that we understand the tactic, which is persistence, and the technique, which is launch agents and launch daemons, then we could come up with a hypothesis. And so that hypothesis is an attacker has compromised at least one system and is persistent via a launch agent or a launch daemon. And so I mentioned before that OS Query is the best tool for doing this because it's the best at doing enterprise sweeps, which is good for persistent items. And so this is an example of a query that you might want to run at an interval. And so I'll walk through this query pretty quickly. And so there's the signature table S, right? And you would join that data on launch D, which includes launch agents and launch daemons. And so you want to grab the program arguments from the signature table where it's tied to launch D, and the name starts with com.apple, right? So that signifies a launch agent or a launch daemon that starts with com.apple. So that takes some things out of the picture. But then also you want to look for unsigned binary in the example that I showed right here, right? And so with that, the sign flag will be 0, right? And so with that, you'll be able to detect something like the cold root rat. And then, as I mentioned before, it's important for it to run at load, or else it doesn't really achieve persistence. And so that's all well and good, but when it comes to defense, you want to consider how robust is your detection for a particular thing. And so we might want to tweak that a little bit to say an attacker has compromised at least one system, and maybe they're persisting via a signed launch agent or launch daemon in which the binary is not signed by Apple. And so there's nothing stopping someone from getting compromised, maybe like an Apple developer, and then the attacker using the Apple developer certificate to sign their malicious code, right? And so you want to account for this sort of thing. Also, the vetting process of actually someone signing up to be an Apple developer and getting a certificate, they could use that certificate to write malicious code. That vetting process of, is this person a sketchy person that might want to write code, malicious code, is not really well documented or vetted by Apple. And so what you have a lot of the times to bypass a certain mechanism, I'll talk about it later, called Gatekeeper, you'll have signed malicious code out there in the wild, and it'll be able to execute because Gatekeeper sees that it's signed, right? And so to take account for this, you would do the following. You would account for com.apple, but then the authority of not software signing, because software signing, it is associated with Apple signed binaries. And if anyone went to Josh Pitt's talk, he mentioned a way to kind of fool Apple's code signature process based on like certain tools out there, open source tools. And so a requirement for that specific technique is the use of the 86 i386 architecture for binaries, right? So you have to use that architecture in order for this type of attack to work. And so if you included that, you'll take into consideration Josh Pitt's technique that he introduced today. So that's from the persistence side. As far as privilege escalation goes, well, you can't do many things on a Mac unless you have some elevated privileges, right? There's something, you just can't, right? So most times on a Mac system, the person who is the main user of the system doesn't create a second account. And so because they don't create the second account, they're automatically admin. So most times if you compromise the system, you're able to get the keychain and dump the password, well then you're able to elevate your privileges, right? But that's not always the case. And so one common way to elevate privileges on a Mac is to give the user a prompt, whether it be through a systematic like API call or through something like AppleScript, right? And so this is a prompt that I created using AppleScript. And if you enter your username and password and you're the admin on the system, then it will execute as an elevated process, or it will be spawned with elevated privileges. And so behind this is just like a simple ls, but it could be anything behind that, right? And so on the Mac systems all the time, you get a bunch of pop-ups and you're not really sure if they're legitimate or not legitimate, right? Apple does a bad job of actually showing that to the user because it happens so many times, but all it takes is one entry into this with username and password and it's game over. And so one hypothesis that we can create is, well, what if an attacker has compromised at least one system and has elevated their privileges through the use of the sudo command, right? So sudo command is similar to that of Linux. You get it, you can use it to elevate privileges. And so one thing that you want to look for in your environment is baselining how often sudo is being used, right? And so if you don't expect your users to sudo much, well then this is something that will give you a lot of good fidelity. So it'll be high fidelity, but it'll be like not that many alerts that come to you, right? And so also, when folks are invoking the prompt for elevated privileges through like an API call, it calls this security off trampoline binary. And so you want to baseline the use of that in your environment as well. Those two things shouldn't happen very often at all in your environment. And if it does, then it's probably tied back to some legitimate tool, whether it be, I've seen Microsoft suite of tools like Microsoft Office. I've seen tools like Little Snitch, but these are legitimate tools, which if you check the code signature on them, they're tied back to like some legitimate entity, right? And so the next tactic that I'll get into is defense evasion. And so in order to talk about defense evasion, you have to talk about, well, what are the different defense mechanisms on macOS systems? Well, the first is file quarantine, right? So the idea behind file quarantine is to slow the user down from executing things that were downloaded from the internet. And it shows me the URL. But one thing about this is that it doesn't prevent the user from opening this. It just shows the user that, hey, like you might want to slow down and think about what you're doing here. So Gatekeeper is complementary, where once you say, okay, I want to open this, Gatekeeper checks to see if it's signed by a legitimate entity, right? So that's like an Apple developer, that's like Apple itself. And if it's not, let's say that that binary is unsigned or the binary is signed by already identified malicious entity, well, it'll ask you, are you sure you want to open this? This came from an unidentified developer or a malicious developer, right? And so it doesn't, again, stop you from opening it. It just tries to slow you down from doing something pretty dumb, right? And so to combat that, you have XProtect, which a lot of people don't know about, which is basically the built-in AV system for macOS systems, right? And so the idea behind XProtect, it used to be like just like SHA-256 hashes that were stored on the system, but they've since moved to Yara-based signatures. And so the Yara signatures are open to anyone to go see. So if you go to the system library, core services, XProtect bundle, and the resources, you can see all of the Yara rules that Apple is actually using to detect the malware, right? And so with that, malware authors can also see the same thing. So they can modify their malware to kind of evade XProtect. And then you have system integrity protection. And so the idea behind that is like Apple wants macOS systems to be rootless. So let's say that even if you were root on a Mac system, there's only so much you can do as far as to compromise a system to like smithereens, right? You can't totally compromise the Mac. There are some folders and files that are protected, even if you're the root user, and that's by design, right? So there's a way to disable system integrity protection, but you have to have physical access to the system, or there's been vulnerabilities that have popped up over the last 2 years where people have been able to circumvent system integrity protection, and it has to do with like malicious, like dynamic libraries and things of that sort. So one way to bypass Gatekeeper that's pretty significant is that in order for File Quarantine or Gatekeeper to notify you that something originated from the internet, what it does something similar to Windows, where it does like a mark of the web, and that's called an extended attribute. So it'll tie the extended attribute to the file that was downloaded and say, hey, this thing was downloaded from the internet. Well, there are some applications on macOS which are not quarantine aware, right? And so one of those applications is Terminal. So if you could simply get a user to run a command that goes to download something, well then it's not quarantine aware. Gatekeeper doesn't know about it, File Quarantine doesn't know about it, and it'll allow it to run. It'll bypass the code check, it'll bypass, hey, did you originate from the internet? And so this instance was from some crypto malware that was targeting a certain community, and it was presented by SANS ISC, right, the Storm Center. And so in this instance, they went to go curl a binary from the internet, and with that, it changed the permissions on that and then allowed the script to execute. And so another way to bypass Gatekeeper is to simply just delete the quarantine flag that's associated with it. So the extended attribute, which is com.apple.quarantine, you could just delete it and it'll allow it to run, right? And so one hypothesis that we want to create is, well, an attacker has attempted to, they have compromised at least one system and is attempting to evade defenses, specifically system integrity protection and or Gatekeeper. And so with this, for OS Query, which is great at point in time, you can check to see if for any of your users, the system integrity check is like disabled, right? So if enabled is equal to 0, which means it's disabled, you might want to know about that, right? Because that's unusual. And then for real-time process monitoring, you might want to look at baselining the use of like curl, get, wget for attempts to download files, specifically for like IP addresses. You might want to monitor it for the use of the system control command to disable Gatekeeper. And then you might also want to monitor for the use of xadder to remove the extended attribute that I just showed. And so I'll get into the demo portion of the presentation in which it'll outline like a attack that happens on the Mac side, and then it'll show you how to go about hunting for that using some other tools I introduced. So this is common. A user gets an email like this saying that, hey, you must download this file. Mojave is coming up to upgrade. These are network settings that need to be updated on the system in order for you to connect to the corporate network. So we want you to download this Apple script, and then we want you to execute this command, right? And so a hypothesis that could be generated from that, from a hunter point of view, is that an attacker has compromised at least one system and is executing malicious code via AppleScript. And so how might this look from a hunting perspective, right? What data might we need and what platforms would we use? And so with this, you have OS Query and XNUMon running on a box, right? And it's collecting those logs, collecting that information that you need, and then that's being fed into Helk. Helk is a tool written by Roberto Rodriguez, a colleague of mine at SpecterOps, which is used for kind of modeling all of your data into one location. So it's SIM-based, but then also doing some additional data science on top of that to get the most out of your data, right? And so then from the attacker's perspective, they could use a tool like Empire, which is a remote access Trojan that could be used for Windows, Mac, and Linux, right? So I'll be using that to carry out my attack in the demo. Right, let's get to the demo. Right, might be a little hard to see this, but we'll walk through it. So this is the attacker activity. So the person has entered in that command just now. They've downloaded the file. And so from an attacker point of view, in Empire, that agent has come up. And so what they're going to do now with that agent, they're on the system with that agent. They're able to take that agent and run a collection module, which will prompt any application on the system, and tell the user that the password is required in order for the application to run, right? And so in this case, I used the App Store application, and so we'll get to see that here in a moment. So I'm setting up the agent and making sure that that's all good to go, and then once it executes, it'll switch over to the end user's end side. All right, so from the end user's perspective now, you see that the App Store came up and then asks you for your password to continue. And so this looks like any normal prompt that you would see on your Mac OS system at any point in time, right? Your users will be fooled by this. And so they entered in their password, and on the Empire side, we see that it gave us some results. And so with that agent now, we could go into the directory that the agent is designated to, and we could see the logs for that particular agent. And embedded in those logs would be the password that was returned by the user. And so we'll get to see that here in a second, and then we could actually use that password to elevate our privileges on the system, because of course this person hasn't separated the admin account from like a normal user account on their box, right? And so it's using the module here to spawn another agent using the credentials that were specified in that agent output. And so here you see I've supplied the password of Apple123, which is what the user entered. And then once that's executed on the box, it'll give us that privilege escalation. You see that's returned to us. A new agent has been kicked off, specified by the green there. And so with that agent now, we can do more malicious things on the system, such as create a launch daemon. So an important thing to note here is that from the detections that I've introduced so far for OS Query, that's been added to the OS Query configuration. And so you'll get to see on the analyst side, when we hunt for this, is a possibility that that analytic might trigger. And so here you see I named the launch agent, the launch daemon, com.apple.network update. And so that's to blend in with all this system activity that happens on a Mac. So if you're not familiar with that as a hunter, then you might come across that and think it might be, legitimate, right? So this is the analyst hunt side now. And so as part of the analyst hunt, we're hunting for AppleScript being used in their environment. So we start our search with OSA script to see how often it's used, if it's used at all in their environment. And so we see that it's been used 62 times, right? And so as it's been used 62 times, we want to see, well, when was the OSA script binary actually executed? How many times did that occur? And you see it's only been a handful of times, right? And so the first iteration of that is when that command that was run by the user to kick off the malicious activity occurred, right? And so we don't know that as a hunter, but we'll get to the next iteration here where OSA script was used to actually prompt the App Store to run, and then the results of that was going to be entered into a file, right? And so that looks suspicious because you see it was like, it's asking for password. So we also see that the child of that using ancestors was Python. So Python spawned OSA script, Apple script, and so that is suspicious, right? So we want to look for, well, how often is Python run in their environment? And so with that, we get some results back, and we're like, okay, there's quite a few Python instances here. And with that, we see some base64 encoding with Python. It was like, well, I mean, unless our developers are doing that, that looks like a bad day, right? And so we could take that, and we can decode that base64 using a tool like CyberChef. And we'll see here what the output of the CyberChef results will be. And so you see that there's an IP in there, and you see get.php. Well, that looks pretty suspicious, right? That's enough probably to kick off incident response process, especially if that IP address is not internal, right? It's internal for the use of this demo here, but if that was to be an external IP or external domain, you might have some interest in that. And so we could see here that because of our analytic that we had from our hunt before, we were able to detect the launch daemon, right? So we detected the launch daemon of com.apple.network update, and so that's a win for us, right? So right now, we've definitely kicked off the IR process, and we know that an adversary is living within our environment. And so another thing that we might be curious about, well, so here you see that it's run at load. Run at load is set to 1, so it's going to persist on the system, and it's going to load whenever the system reboots or starts, right? And so one thing that we might be really interested in is, well, how did they actually elevate their privileges in order to install the launch daemon, right? And so with that, we could go in and we could see how many times have sudo been listed as like an argument, right, in the process execution. And so with that, you'll see that here. And so in Splunk, this is easy. Like you could do like stats count by, and like Elasticsearch is a bit tougher. So I'm going through the process of how to actually do that. And so you see that sudo was at least mentioned 65 times, and so we can filter for that. And then we want to see, well, within sudo, what arguments were passed to the command line when sudo was called, right? And so that would be significant to us. We want to see, like, at what point was sudo used for malicious activity. And so we see that bin shell was used 2 times as opposed to like bash, right? So that's significant enough. We might be a little bit interested in that. And so in the instances where the shell was used, well, what command line arguments were present? And so you see sudo and Python in the same line, right? And so that's pretty suspicious. And so we want to look for instances where sudo and Python were used at the same time. And so we get 4 hits back, but as you scroll down, you see evidence of Apple 1, 2, 3. And so at this point, you're like, okay, we know how they elevated their privileges. We know that they installed a launch daemon, and we could probably tie it back to the file that was downloaded to the system. And so that's just an example of how you would do hunting for Mac OS. All right, and so some of the credits here that are used for my talk is obviously Jonathan Levin's Security and Insecurity book. If you don't have that book, volume 3, it goes into a lot of the details about Mac OS internals, especially from the security aspect. It covers iOS as well. You might want to pick up that book. And then, of course, Objective-C. I'll be presenting this. I've also used the stuff from the Internet Storm Center, as well as Apple, and Hacker News had an interesting article about some of the macro malware that was used for this presentation. And if you want to find me on Twitter, I'm at RRCyrus, and that's the end of my talk. Thanks. I'll open it up to any questions. You could just yell it out. So one thing that I didn't talk about as far as get. So he asked, what would you recommend as far as getting logs off of an endpoint for Mac OS? One thing that I didn't mention that was used in the demo is FileBeat. So FileBeat was used to actually ship those logs from like var log OS query and var log xnumon to ingest into Helk. So, yep. Another question back here. The slides will be posted on my blog, and I'll put it out on Twitter as well. SecurityNeverSleeps.net. Yep. Any other questions? Yeah, so the xnumon tool, right, oh, I'm repeating the question. So Devin asked about the network piece of it. So if someone was to evade defenses and they were to use network, right, how would you go about detecting that? Well, there's no open source tools that do that pretty well today, right? You have to use AuditD for Mac, which is pretty like hard to use, but it does give you network information about processes that make network connections. xnumon, the guy Daniel Roethlisberger is planning to add like network use of, process use of network activity in future iterations of that tool. So that's one way you detect it. But outside of that, you would use something like AuditD. Yeah, I've seen Java Rat being used pretty heavily in a while. So the question was, have I seen like Adwin, like Java Rats being used in a while? That's pretty prevalent on Mac OS systems, and most people don't have Java installed on their Mac anyway. So if you do, then you would target those users and you would start to baseline some of that Java activity. Yeah, especially network connections going out. So you would tie in the endpoint data with your network data to make that correlation. I'll take 2 more questions. So for Mac, that doesn't exist yet, but there's been a lot of discussion about that same thing where tools will start to display, the technique ID that they correspond to, right? Like a specific technique, right? So someone like OS Query would say, hey, we cover these technique IDs, right? That might be something that comes along like down in the pipeline. So. So the question was, what tools do you suggest for kind of managing your OS Query instance, things of that sort? And so with that, I would consider Collide, which is a parent company of like OS Query. And so with Collide, you're able to basically take a query and select what host you want to run that query against. And you could do a lot of the configuration at that like central management terminal for Collide. So that's one tool that I would recommend strongly. All right, thank you.
again?
Oh, yeah.
I'm sure there is.
Hold on. Where's the steamer?
HDMI's right here. Do you want to test this out before you?
What's that?
Do you want to test this out before you put it on?
Mm-hmm. What? Where did it go?
Hang on. Okay, yeah, it's working.
Yeah, it is?
Yep.
Okay. How are you going to? Shit. View text. Good to go. Should we go? Okay. Hi, everyone. Welcome. Thanks for coming by. Not yet. Okay. Before I start, just want to give a quick shout out to DerbyCon for giving us the opportunity to present today. You guys are doing a great job. Right, about it. Go ahead first.
So I am Nick Dulesky. I'm a managing consultant with Spirent Security Labs. With Security Labs, I'm a pen tester, red teamer, focusing mainly on network type attacks. I do also help out with a little bit of embedded wireless and IoT type projects. I'm also a physics enthusiast, so I apologize in advance if any math or science jokes come out in today's presentation.
I'm Saurabh Harit. Feel free to butcher my name. Goes by the handle 0xsobby. I work at Mandiant FireEye, and just like everyone else these days, I'm also a red teamer because it's trending on Twitter. Also a wannabe reverse engineer, and for all the recruiters in the house, I'm also a security researcher, trainer, and speaker. Right, this is what the agenda for the talk looks like. We'll start with an introduction to connected medical devices. We'll talk a little bit about the architecture and workflow of these devices. We'll talk about what are the good aspects of it and what is bad or could be bad. And then we'll touch upon the threat surface from a penetration tester's perspective associated with these medical devices. We'll talk about some of the real-world attacks that has happened against medical devices, and after we have wasted most of the time, then we'll jump into the case studies where we'll talk about the vulnerabilities that we discovered in a couple of medical devices. In a typical InfoSec style presentation, we won't be providing any solution to any of the problems we'll talk about. But there will be some generic closing remarks.
So just a couple of notes about some of the medical devices we're going to be talking about today. They are still deployed somewhat. We are going to be talking about a device that has been improved upon over the last several years with increasing focus on medical device security. However, there are likely still these devices out there in the ecosystem. And therefore, we will have some heavily redacted screenshots. Some details like port numbers and things will be changed. So please expect that.
Oh, this is you too.
So when we're talking about healthcare devices, we're talking about a wide variety of different things. There are, your classical connected healthcare devices, things that you would find in a hospital or a doctor's office, more clinical medical devices. Then you have things that, might be, more aimed toward the consumer market, things that help you improve your lifestyle, Fitbits, health trackers, some apps on certain wearables, that kind of thing. So all of these devices are collecting and processing different data about you. Essentially, it's all data that can, in certain contexts, be construed as medical data. This data is proliferating, sometimes in ways that we wouldn't quite expect. And it's important to take a look at these devices, how they're handling your data, what protocols this data is being transmitted over, and what is done with that data after it's collected and processed.
Right. So we try to classify medical devices into 5 different categories. And the first one, you'd be most familiar with it, are the consumer variables. So your fitness trackers would be part are your HIV detection systems. And then all the devices that I've talked about so far, they are external to a patient's body. But then there are embedded devices which are implanted in patient's bodies. So like most common example would be your pacemaker. And then finally, there are these huge bulky stationary medical equipments that you usually see at the hospitals, like medical dispensing system, MRI machines, CT scanner, and X-ray machines. This is what a typical data loop for an IoT medical device looks like. So the device is always in constant monitoring mode using the sensor. In case of an event, it triggers an action, and then finally the data is aggregated and analyzed. So if you take a quick example of an insulin pump, it uses a sensor to constantly monitor blood sugar level of a patient. And if the blood sugar level drops, it injects right amount of insulin into patient's body using a catheter, which is usually placed under patient's skin. And then once that action is taken, the data is then gathered and analyzed. And I think that aggregation and analysis part of the data is going to be the most important to watch out from connected medical device perspective. In terms of architecture, the device itself on the further left side has a lot of subsystems. So first of all, they can talk on tons of protocols, so Wi-Fi, Lo-Fi, IRDA, Ethernet, ZigBee, Z-Wave. Then a typical connected medical device would have a sensor and actuator to, say, for example, to monitor your heartbeat or insulin level. And then most of these medical devices are actually heavily monitored and maintained by the device manufacturers themselves. So there's some sort of remote access, which also could be interesting from security perspective. It would have a display, a location tracker, especially if the device is something that tracks your steps. Then there's device association module, which would be responsible for authenticating and authorizing a device onto a network. Storage, it will gather data from the patient and then would have some sort of small storage. Event architecture is another important module because it, based on the data it gathers, it analyzes the data and then creates a trigger. And then there's command and control, which is a hacker's paradise. Then middleware, you can think of middleware as like a web server for your medical devices. So it handles most of the code for authentication, authorization, command and control. But I think the most important part would be the database part, because this is now taking all the data from different medical devices and then processing that data, and then it outputs the consumable data set, which can be just fed into through APIs into the third layer, which is like management interface. So like this kind of data can be used by the patient themselves to monitor their health, by the doctors to monitor a patient's health, like, and take preventive measures. By device manufacturers, they can use the data to better the device for future use, and so on.
So why would we want to connect our medical devices? I think there's a lot of people out there that would have a lot of good reasons for why we're doing this, why we're doing what we're doing. Some of it is even encouraged, mandated by legislation in various countries, having to do with electronic health records, the efficient sharing of medical data, the availability of medical data in an emergency, making sure that medical data is portable to various providers and not in proprietary formats. So when you're talking about connected medical devices, there's a lot of stuff that makes sense. It enables remote health monitoring, so you can spend less time in the hospital if a doctor can read your implantable device for signs of heart problems from home. You receive better quality care if you have more accurate instrumentation, if you have instrumentation that is, say maybe remotely calibrated, or the data is able to be sent to, an expert in the field at a moment's notice, as opposed to, an overworked general practitioner who has to deal with all different types of patient complaint at once. You can get some faster response time, again, from that instantaneous communication. Also, telehealth, telemedicine is becoming increasingly popular, where you can actually get, in some instances, a full consultation or examination remotely. I've heard instances of hospitals implementing what were affectionately called robot doctors, where you have essentially an iPad connected up to a remote-controlled car, more or less, and these drive around the ward, and the doctor comes in and say, "Hi, I'm your doctor, I'll see you now." Some people are a little bit put off by the concept, but when that doctor is actually one of the preeminent experts in the country or in the world on that particular malady, a lot of people would rather have that expertise than be put off by the fact that there's that remote connectivity there. In addition, you're able to get early warning of things that might be a trending problem. So, for example, with insulin monitors, if your blood sugars are trending downward, you can send an alert not just to yourself, but if, for example, your sugar is already at a low level, or if your reaction to low blood sugar means that you're not able to see that alert, if there's that ability to maybe get that information to another safety contact, that also has the potential to benefit the patient in the long term as well.
All right, and then obviously there are some nightmares that are connected to the growing number of medical devices. So first of all, I think in my opinion, the biggest challenge would be for hospitals and medical institutions to accommodate large and growing number of medical devices. So I think there are already quite a large number of connected medical devices per bed in modern hospitals in the US. And if you factor in other devices like portable medical devices, which patients might start bringing, then that will also cause a lot of chaos. So hospitals, first of all, must make sure that they have enough bandwidth to support all those devices, and then their wireless infrastructure doesn't choke because of the growing number of devices. There's also the issue of network segregation. So how do you distinguish legit device from a malicious or rogue medical device? So, and also, we will talk about some of the malware in next few slides about how they can compromise medical devices and use them to pivot and then launch further attacks on the hospital system. So last thing we would want is that one compromised medical device affecting the other medical devices or other systems on the hospital network. So that's also going to be important and also going to be a huge challenge to segregate these medical devices. We already talked about how like these medical devices support different kind of communication protocols. So especially devices by different manufacturers, it could be a challenge to get them to talk to each other. Authentication and authorization is also going to be an issue because you need to figure out how to authenticate these devices, and also more importantly, how to authorize these devices to different segments of the network and what systems and subsystems they can access. Patching, a lot of devices are which are now connected, never meant to be connected to the network. So they are typically what do you call legacy medical devices. They never had any connectivity subsystems built into them. And then we'll talk about in the next slide how they're connected to to the network. So there's that issue as well. Right. So like I just mentioned that there are some devices which were never meant to be connected to the network, but here we are because they thought we're connecting everything to the network, so why not devices as well? And so how these medical devices are connected to the hospital network are using serial to Ethernet converters, and that's just a terrible idea. So these devices, they connect to the serial communication port. They've never had any security built into them. In fact, Department of Homeland Security last year alerted against one of the most common used serial to Ethernet adapters, which is N-port, developed by a company called Moxa. I hope no one is here from that company. But apparently, like, there were 3 critical vulnerabilities. One was that would allow an attacker to extract sensitive information remotely without authentication. The other one would allow an attacker to upgrade or downgrade firmware, again remotely without authentication. And as if that was not enough, there's also a buffer overflow vulnerability that you can exploit to get remote code execution on these devices. I don't know if you guys remember, like the unscheduled power outage in Ukraine that happened in 2015. So as per DHS, that also happened because someone corrupted a bunch of these adapters remotely.
So when we're talking about any kind of IoT device, I like to think about it still in the same terms as I would a network pen test or an enterprise network pen test. Layers 1 and 2 may be different, but ultimately we're still just connecting together a bunch of network nodes. Now, in any kind of a pen test, you know that open source recon is going to be a key. It can make your job a lot easier. It also gives you a much more realistic picture of, you know, is this particular vulnerability exposed? Are there any other compensating controls that are out there? So one of the things that you can do with IoT devices, you can take a look at the device itself, you can take a look at the interfaces that are on it. You might be able to download data sheets, you might be able to get regulatory data that's been filed about these devices. That's great, that's one kind of open source reconnaissance you can do on it. Another piece of information, though, that will really give you a lot more insight about the actual risk profile is to learn about the life cycle of these devices. How are they deployed? How are they maintained? How are they retired? As we've seen in the news in the last couple of days, supply chain attacks are real, or are they, depending on who you ask. So if you have a device that you know is vulnerable to a physical attack and it's kept under lock and key and it's also tagged with an active RID or RFID tracking unit, that's a device that, has some of the risk mitigated in there. It might open up some additional attacks, namely being able to tie that active RFID beacon to a particular patient. So you're always making a trade-off. Personally, as I mentioned before, I like physics. I think that risk is an awful lot like the physics concept of entropy, which is entropy is always increasing in the universe. I think as long as we are adding more devices to the network, as long as we are expanding the amount of data that's being shared from place to place, risk is also constantly increasing, and we as security professionals, we're just trying to minimize that increase until we actually kind of reach an equilibrium there.
All right. So I'll talk about some of the horror stories. Actually, there are tons of horror stories associated with compromised medical devices or connected medical devices. But I specifically wanted to talk about MedJack and MedJack 2. MedJack, also known as Medical Device Hijack, is a malware that came out in 2015, lived through most of 2016. MedJack 2 is actually a more sophisticated, newer version that came out in 2017. And so MedJack exploited older operating systems like Windows NT, 2000, 2003, XP, all those. Like one of the interesting things about MedJack was that it went undetected for the most part. And the reason why it happened was because it exploited vulnerabilities like MS-08067, which are like old vulnerabilities. So all the modern operating systems have already protection against MS-08067. So the modern operating system would just drop the packet. It won't even reach the endpoint. And the medical devices which are running the older operating system, they didn't have any endpoint installed on them. So it went undetected for the most part. So it compromised tons of medical devices on hospital network and then used those compromised devices to pivot and launch further attack on the hospital network. It was also known to use Citadel and Zeus malware for horizontal privilege escalation. So yeah, it caused a lot of damage at that point of time.
So the first device that we're going to be talking about is an older model of connected IV pump. Now, what I'm going to talk about today are mostly, architectural and design decisions that were made when this pump was being engineered and manufactured. I don't think that the modern focus and the modern capabilities of the red team or attackers were being considered when this device was designed. So as I've mentioned before, successive iterations of IV pumps have gotten progressively more and more secure, and that's in part to the efforts of the FDA to really put a focus on the need for medical device security. It's also, I'd like to give a shout out to organizations like I Am the Cavalry, who put on the Biohacking Village, or involved with the Biohacking Village at DEF CON, really spreading the awareness of medical device security and helping to increase accessibility of these devices to researchers who just want to make things better for everybody. So I think that there's been a lot of improvement going on here, and we're going to talk about some of the things that we find in these legacy devices that really need to be engineered out of current and future solutions. So as I mentioned, the device is an IV infusion pump meant for injecting nutrients and medication to active patients within a clinical setting, mostly. It is used for controlling the dosage of medication that's being administered, and it has a master drug list on it, and that drug list sets limits so that it reduces medication errors. They can be changed depending on the floor of the hospital, the care area of the hospital, because sometimes you might want the emergency department to be able to issue a certain dosage of a medication that would be maybe inappropriate for maybe a less acute setting, such as a normal medical surgical floor. They used to be completely standalone devices that you can program at the bedside. While those devices are still out there, those standalone devices are still out there, I think that more and more settings and more providers are moving toward these connected devices because they integrate well with EHR systems and other hospital systems. Again, these are random images. It was not this pump that we were looking at. So at a high level, you have the infusion pump at the patient's bedside, connects to a wireless access point. In some infusion pumps, it might use a proprietary access point that uses ISM band communications that are dedicated to medical devices. In some instances, it might use the same Wi-Fi frequencies that are available to everybody else. And then through that access point, it'll connect to a gateway, possibly to some cloud services back at the manufacturer for updates or other telemetry data. And then most often, they also have some sort of a server component on premises. So that way, all of these devices can report back and be managed centrally in the case of a mass update of all of the devices that are out there in the field with a new master drug list or other clinical type settings. So with this particular device, we took a look at the different interfaces that were available to us. So there was 802.11 BGA using standard frequency ranges. So that equipment to assess the security of that part of it was readily available. It had some proprietary power connectors on it. Generally, in order to charge a battery-powered device, you might need voltage in. You might also need some sort of data for smart charging capabilities or some kind of data transfer regarding how much power is left. So we did take a look at that, but didn't find anything particularly interesting there. It also had an IRDA port, normal LCD display, keypad, and what we found was that there was a maintenance mode accessible through the keypad UI with a guessable password. So that provided us with some read-only access to the device. The actual interface in that maintenance mode did have an option to upgrade and downgrade the software. We looked high and low to see if we could find copies of the software and see if we could extract anything from the binary. Luckily, access to that data is pretty well controlled. We weren't able to find anything on that, so we could tamper directly with the device. So the next path that we took was taking a look at the different network interfaces. So since the interface was only readable on the UI, we took a look at a feature of the device which allowed us to change the network settings via the IRDA port. So I had taken a couple different ideas under consideration. First was, all right, well, we could go out and buy an IRDA interface over USB. Seems like the reasonable course of action. But that was going to take a little while to get to us because it's not really a common component anymore. So that was out. I had some some IR LEDs and IR sensors in my parts bin, so I considered all right, do I try and cobble something together with an Arduino and a Raspberry Pi? And I thought to myself, well, that's going to take just as long and probably be 4 times as frustrating. So all of a sudden I had an aha moment. You know, this device was engineered quite a while ago, so I looked at other technology that was available quite a while ago. And ultimately what I settled on was handspring visor. Cost me about $10 at a local pawn shop. So I am one of those people that will hoard electronics from days of yore and say, I'll use that later. And much to my wife's dismay, this did actually prove that point for me in this case. So once we were able to change the wireless settings, we now had the device on our network. So what I'd like to note here is that the overall design of the pump handled wireless communication fairly well. We tried to perform an evil twin attack against the pump. It was completely unsuccessful because it appeared to be checking the server-side certificate on the WPA enterprise network just the way it should have been. Likewise, we tried setting up a rogue access point that didn't have any encryption. It didn't fall for that either. Finally, we couldn't just extract the credentials or the network data using IRDA. So when the update function basically just sent a copy of the configuration template to the Palm Visor, and it had some rudimentary authentication mechanisms that we were able to get past because we had physical access to the device. So after we took a look at the template, we found that it didn't share any pre-shared keys in that template. It didn't share any usernames or passwords. So somebody had clearly thought of the security basics here. They just maybe didn't go quite far enough in the engineering of this device. So what we did was we substituted our own information, just hooked it up to our own wireless network. In a clinical setting, this would be raising all kinds of red flags. The device wouldn't be reporting back. So this is more emblematic of what happens with IoT devices that are maybe accessible. Controlling where those IoT devices are can be key because what if one of them gets compromised? Are you able to recover your security if there are key secrets or key trusts that are placed in that device? So that's really what this illustrates here, more than any kind of a James Bond-like or Mission Impossible-like scenario with this particular pump. So once we had the device on our network, we were able to learn a little bit more about the protocols that it used. Notably, we see Telnet FTP, which obviously are plain text protocols. Anything having to do with medical data, medical devices, plain text should be in big red letters a bad thing in any sort of design documentation, whether it's for management or whether it's actually transferring patient data. Obviously, with Telnet and FTP, it also sends authentication credentials in the clear. So again, if this were a real-world scenario, if, for example, we were able to get access to the wireless network that these devices were on by some other means, say via VLAN hopping or through compromising another network node, there's a pretty good potential we'd be able to man-in-the-middle sniff this traffic and get those credentials. As it is, we just had the device in our lab, so we didn't have any valid clients reaching out with valid credentials, so we had to brute force. In the time that we had, we weren't able to brute force either Telnet, FTP, or SSH. Maybe we just need better word lists. So in addition to taking a look at the pump from a server side, we also took a look at its natural interactions with the network, and we saw that it was attempting to resolve a certain host name. So, being that we controlled the network, say, okay, we're that host name. What we found when we set up a Netcat listener based on that traffic was that it was using a plain text protocol that looks like some ugly XML followed by a short trailer. contained a lot of descriptive information about the pump, but not really anything that we would see as sensitive medical data. We tried to respond back with the same sorts of data, and we were getting we were having some varied results there. Mostly we were just getting back what looked to be some kind of a formatted error message. That's until we took a look at the trailer. The trailer that they have at the end of that data turned out to be a simple X-modem checksum. So clearly they were concerned about the integrity of the data in transit, not so much the confidentiality. And the integrity check is good, but it needs to go a little bit further. Given that it was just an X-modem checksum, we could now craft packets that looked as though they were valid, and integrity-checked packets from the perspective of the pump. What would be better in this sort of a situation would be something more like a signature as opposed to just a simple checksum. Now, once we were able to send some properly checked traffic back to the pump, it started giving us a lot more information. There were actually two different services. There was one outbound from the pump, and then there was another service going back from the simulated pump server back to the pump itself. And then that service used the same basic data format with a couple of differences. Once we had learned a little bit more about how that communication occurred, we were able to create a custom Python library to interact with the pump in both directions, and we did some fuzzing. There was a message type field in some of that data that we were able to enumerate. We went from 0 all the way up to 254. Most of the message types didn't do anything, but a quick summary of what we learned is here. Type 2 appears to confirm that, yes, I am trying to associate to this pump server. And then type 8 is also a related message, and that's when the pump seems to really say, okay, yes, I'm part of this network. I'm going to start giving you more information now. Type 7 and 31, we're not really sure what they do. They caused maybe a 7 or 8 second delay before responding back with sort of a generic message to us. Same thing with message types 208 and 238. Message type 20 turned out to be a little bit more interesting. That when we sent message type 20, the pump responded back with information about its own wireless card as well as the wireless environment around it. So neighboring BSS IDs, MAC addresses, and signal strengths. So somebody who is able to access this pump and send it a message type 20 might be able to find out where this pump is physically located through similar open source reconnaissance methods. So here's some of the types of data that we were able to get out of the pump once we successfully associated it to our Python library. As you can see up there, it has the pump status, whether it's on AC power or battery. It also has the drug and the dosage. It even has information about the caregiver that is either programming or administering the pump and its medicine. So clearly there's some protected data there that's potentially at risk if there were an attacker that were able to get a position on this network. Now, I mentioned the master drug list before. That is something that would be pushed down from the pump server to the pump itself. We had some indications that with some of the communication we were able to fuzz. We're highly confident that we would have been able to update the master drug list. We didn't have that pump server software in our lab to view this traffic, and so we could modify it and work off of it. So again, that's kind of a limitation of this particular lab setup. But to be sure, I think that with the other architectural decisions and design features of this pump, I'm fairly confident we could have updated that master drug list. And again, that would have some definitely patient safety, patient care impacts.
Yeah, like one of the things you can do when you can override master drug list is that one of the safety features of infusion pump is that doctors can set a limit to the higher dosage. So for example, they can set a limit to morphine to be 100 milligrams, and once that is set, even if patient wanted to inject more morphine, they can't. But if you can override the master drug list, you can actually cause harm to the patient. All right, so the second device that we looked at was a digital pen. The pen is used by doctors and medical practitioners to electronically write prescriptions on a special paper, and then that gets electronically transferred to the pharmacy. So the benefit is that you save time. So by the time you reach pharmacy, your medication is already ready for pickup. It didn't look like much of a device, to be honest. Like when we started looking at it first, we thought, oh, the most we can get out of it is maybe like a few prescriptions, and that's pretty much it. Clearly not the case. These devices are manufactured by many manufacturers. We only looked at one device from one manufacturer, and this is definitely not that device for sure. In terms of workflow, the device itself sits on the private hospital network, connects either Ethernet or Wi-Fi, and then the prescription is sent to a cloud server. And on the server side, there's a web portal, so the patients and doctors and admins can log in and see the prescription, an app server, and a database. We initially noticed that it comes with a Windows 10 operating system, so we thought, okay, at least it's not XP. It came with two different accounts. One was a nurse/physician account, so which is typically the account your medical practitioner would use to write the prescription, and then the other one was administrator, which is typically used by device manufacturers to update, troubleshoot the device. I think I was the only other person who used that account. Then there was USB. It had wireless and Ethernet capabilities, HDMI, VGA, standard display port. It came with a fully updated Windows Defender. There was also a docking station, so you can dock the pen to charge the pen. And software layer, which basically comprised of two applications by the manufacturer. All right, so because it had HDMI, we could connect a monitor to it. Because it had USB, we could connect keyboard and mouse to it. And so we noticed that when you boot up the pen, it automatically logs into the nurse account, which is a lockdown mode, but it was still something. So you had access to Windows 10 operating system in a very lockdown mode. Then there were like a couple of applications that were provided by the manufacturers, and then there were a couple of services that were running by the manufacturer. This pen, so like when doctors use the pen, if it's connected to the internet at that point of time, it will transmit all the data in real time to the pharmacist. If not that, the pen used to store data in an encrypted manner on the disk, and then transmit it over when it connects back to the internet. The data transmission itself happened using SSL, so AES-256, and we looked into it, but there wasn't much in there. There was also a remote access component, which involved using TeamViewer to remote in, again used by manufacturer, which I think could also be a very interesting factor to look at. So like from a pen tester's perspective, we already had access to the operating system, but it was low privilege and locked down. So initial thought was to just update access to local administrators. So basically I could change the screensaver because I didn't like that one. We started looking at different services, and because it was a lockdown mode, we couldn't restart, stop services. We tried some of the exploits that are out there against Windows 10 that also did not work. But then we found this service, which is actually by the manufacturer. Although we couldn't stop the service, we could replace the binary of the service on the disk. Nothing really rocket science here. So we created a payload which would create a local admin user, replaced it with the original binary for that particular application. Since we couldn't restart the service, we just rebooted the pen. So as it came back up, it created a local admin account on the system. So at this point of time, I could indeed change the wallpaper. We also installed some other tools like Wireshark, and then also Windows System internal utilities. So we started looking at Wireshark, and there wasn't much in there because the traffic was mostly encrypted. I'm not that technical, all that stuff. But after that, we fired up Procmon specifically to look at what are the different events that happen, what are rewrite operations, registry operations, and so on. And if you've ever used Procmon, you'd see that it captures tons of events. And surely, like, you can set a filter to capture from single application, but still ends up a lot of events there. So cycled through them for a long time, and then we realized that the application reads a file with extension .enc. So we figured it will be an encrypted file. We located the file on the file system, opened it in Notepad, and it was all garbage. So yeah, definitely encrypted. Remember I mentioned I am a wannabe reverse engineer, so I put in Ollie debugger in there. Just wanted to reverse engineer the application, so started doing some dynamic and static binary reverse engineering on it. And so, like, after several hours, figured out that the portion on the left side is actually the logic that would decrypt that file. So what application basically was doing was it was reading this file in memory, decrypting it, and then reading some of the parameters from it. So it took another little while to reverse engineer the logic for decryption, and what we ended up doing was just writing a Python script that would locate the file on disk, decrypt it, copy the contents, and paste it on another file. We didn't really have to do it because if you look at the bottom area there, that's already decrypted data. So like when it decrypts it, it will show up there. But just wanted to be a bit more fancy than that, I guess. So we opened the file. If you can see, it has a database string in there, so for MySQL database. So it's got host name, IP address, it's called database name as well. Username, you will see it's root, which is the highest privileged user. There's also plain text password. So we're like, okay, it's there. It has to be written in data. It's there. They're not probably using it. But then we had to do an Nmap scan, and there it was. The database itself was exposed over the internet. And like even at this point of time, we are thinking this is like one of those OSCP CTF style things where they want you to think that that's a vulnerability, but it's not really there. But we connected to the database, and there it was. So at this point of time, because we were connected to the backend database and not just through the portal, we could access the patient health record from all the institutions where these pens were installed, and not just our test pen. So essentially millions of records were in there. So if you can see, like I've redacted most of the data because it's real world patient data, but there's patient code in there, patient first name, last name, date of birth, gender of the patient. And then we found tons of data. Like this is another table where you can see the username, email ID, the passwords were in plain text, and then there's something called a roll code, and which basically says if this account belongs to an administrator, a manufacturer, a patient. So we pulled out some of the credentials in there, logged onto the portal itself. Here again, you can see the resident name, the unit, home address, room number, HCN is healthcare number, I suppose. And then finally, we were also able to pull out prescriptions that were written by the doctors for different patients. So like tons of them, there's no point collecting all that information. Yeah, so we thought that was pretty cool, but not the prescription part. So these are some of the vulnerabilities that we found in these two devices. It's hard to get your hands on medical devices, so we work on them as in when we get the chance. In terms of closing remarks, I said, like, as I mentioned before, going to be very, very generic. I think Nick did mention some of the good points during his coverage. But I know there's a lot of rush in bringing all these medical devices, not just medical devices, the IoT devices out to the market, but there isn't any security built into them. They're just trying to bolt on the security as someone finds issues, and it's more like security by obscurity because not a lot of people are looking at these devices, so they get by in the market. Again, there's going to be tons of medical devices on the network, so from medical institutions' perspective, they have to make sure that they come up with a model to trust the devices and also blacklist the untrusted devices. Nick mentioned that FDA is they've started to pay a lot of attention to medical devices, but we still need to go beyond regulations on that. So I don't know, for whatever reason, as per FDA regulation, once a device is tested and deployed at a health institution, you're not supposed to change anything on those devices because of how they might react to those settings. So, which basically leaves these devices strictly at the mercy of the manufacturer. So the IT technicians at the hospital don't have any insight into the device, so it's kind of a black box for them. We can learn from past mistakes. I think any of the issues that we talked about today aren't exactly 0 days. They have already happened with your web applications, your other hardware, mobile applications and all. So we're not learning anything new here. We just have to be, just learn from the past mistake and use those while building the new devices. And that's it. Thank you. If you have any other questions for